Let's analyze and solve the ransom note coding problem. We are given two non-empty strings, ransom note and magazine, and we have to return true if we can form the ransom note from that magazine, otherwise we have to return false. From the coding perspective, we have to write a function, we can call it construct, and the function will have two arguments, ransom note and magazine, and the function will return a boolean value, true or false, depending whether the ransom note can be constructed from that magazine. We are also given a set of constraints, which tells us that magazine and ransom note are never empty, and we are also being told that they use the lowercase characters only. Let's take a look at the examples. In the example 1, we have ransom note ABC and magazine CBAD. In order to check whether we can form the ransom note from that magazine, what we have to do is go through all the letters in ransom note, starting from the first letter, which is A, and see if that letter is in the magazine. In our case, it is there, so we mark the letter as used. We move to the next letter in our ransom note and repeat the procedure. So we search for B in the magazine, we mark it as used, and we move to the last letter and we again search the magazine. The C is in the magazine, so we mark it as used, and we reach the end of the ransom note. That means we can build the ransom note out of this magazine and we can return true. If we had slightly different ransom note, let's say our ransom note was ABCE and the same magazine, we would find out that A is in the magazine, B is in the magazine, C is in the magazine, but E is not in the magazine, so we would return false. And the last example would be, let's say our ransom note is ABCC and our magazine is the same. We will go through the ransom note again. So A is in the magazine, B is in the magazine, C is in the magazine. We mark the C letter as used, and we have another C, and we search the magazine, but there is no second C in the magazine, in which case we have to return false. And that's the entire ransom note problem. To solve this problem, let's start from a brute force approach. And what we can do is to simply go through every letter in our note, starting from the first letter, and then try to find it in the magazine. And if we find it, we will erase it from the magazine. So after that operation, our magazine would have letters C, B, and D. And we would move to the next letter in the ransom note and repeat the procedure. So search in the magazine, we found the letter, we remove it, magazine changes to C and D, and we move to the next letter, which is the last letter in this case. We search through the magazine, we find the letter, we remove it from the magazine, and magazine now just contains a letter D. So for this solution, if we ever have a situation that we are searching through the magazine and there is no letter, we of course return false. If we reach the end of the node and we found all the letters, we will return true. The time complexity of this solution is O of n times m, where n is the size of the node and m is the size of the magazine. And it is n times m because for every ransom node, we have n letters in the ransom node, we have to do a search through the magazine and erase the letters. So it is n letters in the ransom node times m searches in the magazine. The space complexity is O of 1. We are not using any additional memory. And sometimes in the interview settings, the interviewer may ask you whether if we copy the parameters like we are doing in this case, note that the ransom node and magazine are passed by value, so they would have to be copied from outside. They can argue that the space complexity is O of n plus m because we have to copy both strings. but typically we are not accounting for this. We are assuming that we are given the strings and we can use them in any way we are allowed, and we do not account for that extra copy. But this is something to remember in case you are asked for that detail. And that's pretty much all about the brute force solution for this problem. The brute force solution works, but we can improve time complexity by doing the following. We can pre-scan the magazine and store the information of what letters are in the magazine and what is their frequency. To do that, we can introduce a map. The map will be from the character to the integer. The key in the map will be a character in our magazine, and the value will be how often it appears in the magazine. So if we were to scan this specific magazine, we would get C1, B1, A1, and D1. If there was another D in the magazine, for example, if we had like a D and another A, we would continue scanning the magazine, so we would find a D and we would increase the value to 2. And the same would happen in the case of A. We would find another A and we would increase the value to 2. With the map ready, we can start processing the ransom note. We start from the first letter in the ransom note. We check whether this letter exists in the map. If it doesn't, then we return false. If it does, then we decrease the counter and move to the next letter. We again search if it is in the map. It is, and so we decrease the counter and move to the last letter. We decrease the counter, and since we reached the end of the node and they were all in the map, then we can return true. If we had, for example, one additional C in our node, we would process that C. We would search if the C is in the map. It is. We would decrease the counter. The counter would become -1. And at this point, we would check whether the counter is negative. Then we return false. So the idea is, in general, to pre-scan the magazine, count all the letters, and then scan through the node. And for each letter, decrease the counter in the map. And when we reach the situation when the counter is 0 and decreasing it would make it to go to negative, then we return false. And that's the entire idea for a better solution. The complexity of this solution, the time complexity, is O of n plus m, because we have to process the magazine just once, and we also have to process the node just once. But the time complexity has increased. It is O of m, because in the worst case, if every letter in the magazine is different, we need to store n letters in our map. And that's the better solution for this problem. Our solution which uses the map works, but since we are given additional information that the input strings only contain lowercase English letters, and there are 26 English letters, we can make a small optimization, and instead of using a map, we can use an array. So we would use an array to store our frequency counters, and this would be an array of 26 integers. So we would have an array with indexes from 0 to 25. And for each character we are processing, we would subtract an A from the character. So for example, if our current character is A, we would subtract A, and the result would be 0. If our character we are processing is B, we would subtract the A, which is subtracting the code of A, and the result would be 1, and so on. And for the last character, Z, when we subtract A, we would get 25. So in other words, we would change the map from char to integer to array, where the index of the array is playing the role of our key, and we would compute the key using this simple procedure of subtracting the code of A from the current character, which would map the current character into index range between 0 and 25. This optimization would not change the complexities of the algorithm, but in practice it would make the algorithm slightly more performant because array can be allocated on the stack, while the map uses the memory on the heap to store the keys and values which are in the map. And that's the final optimization of our algorithm. Let's write code for our solution starting from the brute force solution. So we are going to process each and every letter in the ransom note. And for the current letter, we are going to search the magazine and see if the letter is in the magazine. The function find will return a special value and pause if the letter is not in the magazine. So we are going to check whether this value was in the magazine, and if it wasn't, then we are going to return false. Now, if the letter is in the magazine, we will erase it from the magazine. The erase method takes the position from where to erase and how many characters. And if we are able to do it for all the letters and we exit the for loop, that means that we can construct the note, so we will return true. And that's the entire algorithm. Let's build it. It builds okay. Let's run tests, and all the tests have passed. Let's write the code for the solution that uses unordered map. So let's first define the map. Our map is from char to int, so the key is a character and the value is int. And let's now populate that map from the magazine. So we will process all the letters in the magazine and increase the frequency of that letter inside our map. So now our map is populated, and for each letter we have a count how many times it was found in the magazine. Let's now process the ransom note. We again go through every letter in the ransom note, and for each letter what we will do is we first will decrement the value in the map, and if the value goes below 0, we will return false, because that means that the letter was occurring more time in the ransom note than it was present in the magazine. And to write a shorter code, we will use a pre-decrement operator. If there was a letter in the ransom note which wasn't in the magazine, because we use square brackets to refer to our map, the map would initialize the value for this letter to 0, and the decrement operator would turn it into -1, so our condition would become true and we would return false as expected. If we are able to go through the entire ransom node in our second for loop, and if we leave that for loop without returning false from the line 14, that means that our ransom node can be constructed from the magazine, in which case we have to return true. And that's the entire algorithm. Let's try to build it. It builds okay. Let's try to run the tests. The tests have passed, so we have successfully coded the algorithm that uses unordered map. Let's write the code for the solution that uses an array to track the frequencies of the letters in the magazine. For that, we are including an array header. And let's start from defining the array. So our array has 26 integers. 26 because we are taking an advantage from the constraint that told us that we are only dealing with lowercase English letters, and note that we are initializing the values in that array to zeros using the universal initialization. With array defined, let's now process the magazine letter by letter and increment the frequencies. We are using a for range loop to process the magazine, and for each letter in the magazine, we are increasing the frequency. And in order to shift the range inside the index, we have to subtract the code of letter A from the code of our current letter. And this operation will shift the index to be within the boundaries of our array, which is between 0 and 25. With the map populated, let's process the ransom note in the similar manner. For each letter in our ransom note, we are going to decrement the frequency, and if the frequency goes below 0, that means that we have to return false, because the letter, the current letter we are processing, was found in the ransom note more times than it was found in the magazine. Note that we are using a pre-decrement operator, and the way it works, it will first decrement the value inside the array and will check against 0 only after the decrementation was done. If we are able to process all letters in the ransom note and not return false, that means that we can construct the ransom note. In this case, we just return true. And that's the entire code. Let's try to build it. It builds OK. Let's try to run tests. All tests have passed, so we successfully coded the solution using an array. Let's make sure we can pass all LeetCode tests. So let's start from the brute force solution. Let's see if it works. It works. Let's try to submit. And we were able to submit. So let's now try the solution with the map. Let's see if it works. It works. Let's try to submit. We were able to submit this solution. So let's try the last solution that uses an array. Let's see if this solution works. It works. So let's try to submit this solution. And we were able to submit. So all our solutions work and are passing the LeetCode tests. This is the end of this solution. The source code is available in the GitHub repo shown on the screen.